Am I plugged in? I am plugged in. But I do not appear to be recording. Yes, it is great. Yes, I got the little red light right there that says I'm working. Okay. Now, determine the expression. Now, of course, all you needed to do there was show me your work, exactly what I asked you to do. So you could have done of CB, you could have done cos 32 equaled CB over 16. So 16 cos 32 would have been one answer you could have used. You could also have done, since you knew that was 8.5, you could have used tan 32 equaled 8.5 over CB. So CB equaled 8.5 divided by tan 32. You could also have done Pythagoras, and CB would have equaled the square root of 8.5, oh, I lie, the square root of 16 squared minus 8.5 squared. All three of them would have worked. And as you can see, this is why I'm not marking this, because whichever one you did, right? And then, of course, you got an answer. I can't remember what the answer was. I think it was 13.26 or something, or 6.2. I can't remember. 13-ish. The height of AC is, of course, 8.5. And you needn't do any trig for that, because AC was the same as CD because they were both 45-degree angles, so it had to be an isosceles triangle. So that was 8.5. And A to D was, you could have done the square root of 8.5 squared plus 8.5 squared. Or you could have done tan or, not tan, I'm sorry, sine or cosine with 45. And you would have gotten the same answer. I don't remember what that answer is. I believe it is something along the lines of 11-ish. Everybody okay with the first page? Lovely. Second page. Oh, wow. This question causes so much trouble for everyone. This is something like 83. Yes, Lauren?
For number 4, I did 16 sine 32.
You did, I'm sorry, 16?
16 sine 32 divided by cosine 45.
16 sine 32 divided by cosine 45. Yeah, because this was 16 sine 32. And yeah, of course. Yep. This question, I don't fully remember, but I think this is 84, actually. But I don't totally remember. But I should go over it anyway, because people have a lot of trouble with this question. Here's the airport. The plane is 37 north, 81 east. So if the plane were on the ground, it would be right here, wouldn't it? That hypotenuse, yes? Which would be the square root of 37 squared plus 81 squared, yes? But the plane is not on the ground. The plane is 6K in the air. So the line you actually need is this red line with that side and 6. You actually need this hypotenuse, which is, of course, the square root of 6 squared plus this one, the square root of 37 squared plus 81 squared. So if you were writing it all out, that is what you should have had before you touched your calculator. Does everybody understand? Yeah. Now, please tell me that the drawing is understood perfectly. Or do I need to talk about that? Is everyone okay with that one? It's hard to draw, right? That was the problem. It was very difficult to draw in one drawing. I recommend to a lot of my students to draw two drawings. There's the ground, and then there's this one. That number comes right there, and the plane was 6K in the air. Everybody cool? Okay, so that was your answer. And I believe it was something around 84, but I'm not totally sure. I don't have my calculator out, so I'm not going to do that. Somebody must have done it. Somebody in the class attempted this. 89? Sure. Okay. I believe you. Now, the angle along the ground that the airplane is as a direction east of north. So, the area angle along the ground. Which angle is that? There or there? There's the port. There's the plane. Is it the angle at the airport or the angle at the plane for which I seek? I need the one that is east and north from the airport, right? So east of north. So what does that mean? Which way am I starting to go, north or east? I'm adjusting east of north. So I must start north and I adjust to the east. And in there goes the adjustment, yes? How do I figure that adjustment out? What angle is that? That is my theta. What sides do I know? I know 37 and 81. I also know the hypotenuse now, but I already had 37 and 81, so I could just use that, yes? And it is what? It's tan, yes? Opposite over adjacent. So this in here would have been the shift tan of 81 over 37, which is, somebody said something like 60, 65. That's cool. And the angle of elevation, well, if I went up 6, and I have both of these sides now, I need the angle of elevation. I can use tan, sine, or cos. It doesn't matter. And the answer is 4 degrees-ish. Is everybody okay to there? And the rest of it is very straightforward. Again, I am looking for your work. Height of the tree, 52, tan, 32. Right? Total distance from the bottom of the canyon to the top of the tree. Well, that would be 52, tan, 67, plus what? 52, tan, 32. And I believe this answer is somewhere in the neighborhood of 27, 32. Great. And this one is something like 122. 155. Well, there were two numbers the same in it.
Well, 155 would be the total.
The total, yeah, because that's what the question was. Oh, yeah, right. This part was 122. Yeah. Okay. Erase. There we go. This was directly in. Now, this was right out of your notes. Trees are 100 meters apart. So this is 50, 8, 13, X, Y. Set it up. I need to know which one is taller, Y or X. I got two answers. Josiah says X is taller. Leighton says Y is taller. Which is taller? Look at it. Why is Y taller?
Because they're both the same distance from the truck. And it takes more.
The angle is greater, so you had to go higher up, yes? Yeah. So this is your taller one. So your final answer has to be Y minus X, yes? The way I have set this up. Yeah. You might have made this side X. The point I'm trying to make is the side that is using tan 13 is the taller side. Yeah? So it was 50 tan 13 minus 50 tan 8 to get the answer. And the answer is something like 4 meters, I think. 5 meters. Again, it doesn't matter because I am more interested in this part. Everybody cool? All right. Now, one thing I forgot to do, I'm an idiot, and if you did this wrong, you're not, don't worry about it, because again, I care about process. I forgot to say, because it's visible on mine, you can quite plainly see my black line from Curtis Point to there, but it's not on your photocopy very well. This is Curtis Point, right there. Okay? Curtis Point is not a dot in the middle of the ocean, because then it's not a point, right? A point is a chunk of land, all right? So if you did this wrong, it's no problem. Don't worry about it. It's my fault. It's not yours. But let's work through it. The first question says, I sailed from Roberts Point to Coal Island to Fernie Island and then home. Roberts Point to Coal Island to Fernie Island and then home. There's your triangle. So I'm going to draw it out here bigger. There is Coal. There is Roberts. There is Fernie. Where is the 16 degrees that it says in the question? Where does that go in my triangle? At C, R, or F? It is indeed at R, because I left at that heading. The question tells me Fernie Island is due north of Roberts Point. So this is north, which means that's where I start counting from. 16 right there. And you know this side is 1750, which is, of course, going to write on in a moment. And then again, is there more than one way to do this question? Yes. I'm going to use trig only. So to find this side is 1750 divided by cos 16. And then this last side is opposite over adjacent. 1750 tan 16 plus the last side, which we knew to be 1750. And then you added it all up. That's the way I would have done it. Could you have used, well, you needed tan, you needed cos. Yeah, that's, that's, for me, that's the sensible way to do it. And the answer is something like 4K, 4,072 exactly, or ish. Okay. Everyone's cool? Okay. And then the next question, I'll use the same map, was Curtis Point is 800 meters north of Armstrong Point. So let's get a color that shows up well again. Let's use pink. Does that show up?
Yeah.
Okay, so there's 800, and then I sailed over to Kingfisher Point, I believe. Yes? Which is over there, and then down. So I have that pink triangle, which looks like this. And that is Armstrong Point to Curtis Point to Kingfisher Point. Bearing of 307. Where's the 307? Where's the north? Which side is north? AK, AC, or CK? AC. There's the north. So that's where I start counting from, yes? And I count clockwise, right?
Yeah.
So if all this is 307, what's this? 37. 53. Because all the way around would be what? 360. So there's your 53. Right? And you knew this was 800. And then you needed all three sides again. So I would have done 800 over cos 53 plus opposite over adjacent 800 tan 53 plus 800 and gotten whatever that was. I don't know what it was. What'd you get? Yeah, you, because you're the one that said 53. You did it wrong. Did anybody do it right? Nobody? Curses. That means I got to do math. Man, I hate when I have to do math. 800. Yes, it is.
Wow.
Plus 800 tan 53 plus 800. 3,190.5. 0.95. All right, this question is the airport question, of course, just done differently, right? So I gave you the diagram. I'm a nice guy. How high is the cliff? That is this side right here, yes? So to do that, I need two pieces of information, which I would get right there once, because I have 43. So if I can get that green side, I'm in business. That green side is 30. No, I lie. No, I don't lie. 30 tan 69 gets me that green side, right? And then I got to use tan over here, opposite blue side over adjacent, right? So this is the unknown, so that's what I get there. 30 tan 69 times tan 43 will get me my blue side, which is 70-ish. I don't know. Let's find out. 30 tan 69 times, oh, that was an extra bracket, you dummy head. 30 tan 69 times tan 43. 72.87. Nice. So 72.87, which is, of course, 73. Not degrees, you dummy. Meters. Yeah? Guy wire question. The anchor point of 1 is 9.8 away. 9.8. The angle of inclination is 37. Uh, 9.8, 37. The angle of elevation to the top is 58. So that's how you needed to do it, right? So you needed this distance and this distance. Or did you? Let me read that question. Angle of elevation from this anchor point to the top is 58. How tall is the tower? Oh, so height of the tower, you only needed the 58, right? So that would have been opposite over adjacent. 9.8 tan 58 equals height, right? But I'm not going to my calculator. Well, I would have had to go to my calculator because I wanted how tall is the tower. And then how far from the top to the tower is this one? So then I needed this distance, yes? Which is going to be 9.8 tan 37, right? And then the answer to that question, though, is 9.8 tan 58 minus 9.8 tan 37 to get an answer of whatever it was. What was it? Height of the tower was what? 15.7 and 8.3. According to Leighton. I trust him. And find one of the world's longest suspension bridges. Why is this a bad question? Why is this a bad question? It's a bad question. I put it in on purpose. Why is it a bad question? Kayla.
You assume that everybody knows what a suspension bridge is.
Yes. You all should know what a suspension bridge is because every bridge around us, well, not every, most of the bridges around us are suspension bridges. The Golden Ears, the Portman, the Pitt River. That's a different kind of suspension bridge. But no, that is not.
The Alex Fraser.
Alex Fraser.
Yeah.
Nice.
That's the one I remember.
Yes. A suspension bridge looks like this. Tower, wires. That is a suspension bridge. The towers are 135 above the levels of the bridge. 135. The angles of elevation from the center of the bridge and either end are 10.8 and 18.65 respectively. So from the center, 10.8. From the end, 18.65. How long's the bridge? So you found this side, then you found this side, and then you did what with that whole answer? times by 2. This side would have been opposite over adjacent. So 135 divided by tan 18.65 plus 135 divided by tan 10.8 times 2. Then you go to your calculator. And it's something like 2,000 meters. 2,100, I think. Is everybody okay with SOHCAHTOA trig now?
It's so.
It's so Katoa. Toable? Oh, yeah. Yeah. How are you with trig? Katoa. What do you mean? I'm so Katoa. All right. That's how you got to say it. No!
I probably. I feel like it's like a Russian meal, like a delicacy. Russian delicacy. I need some toa. Why Russian? I don't know.
Who wouldn't like some Katoa? It sounds delightful.
I'm gonna look it up.
All right. Okay. Not Catelli. It's not spaghetti in a can. Okay. It is not Chef Boyardee.
Chef Boyardee.
Spaghetti in a can.
Chef Boyardee has boy in it triggered.
What are you talking about? All right. Let us please turn to page 72, cabbages.
Get it? Lettuce, cabbages.
Yep, joke never gets tired.
Cabbage patch kids.
Okay, so, guys, I'm not assuming anything. I only want the attention of people that identify as guys.
Actually, okay, go.
So I am only asking for the guys' attention right now. Don't assume you know what I am asking about. Since the only people making any noise are you two, and you two have both plainly identified as guys recently. Yes. So,
Acting now is pretty.
the fact that you're acting like clowns is a good example.
Yes.
All right. What do you know? Remember, everything new in math comes directly from stuff you already know. So what do you already know about the sine ratio of theta in any question? What do you know about that? Fire. You know that it is O over H. And you know that cosine is A over H. And you know that tan is O over A. You know all of that already, yes? Yeah. Excellent. Now, look at the thing I have drawn here. There are two things that we have talked about in math that use this construction. One is northeast, southwest. It is not that. What is the other thing we use this construction for? The x and y axes. Yes, this is the coordinate plane or the Cartesian plane, but we don't call it Cartesian anymore because that gives credit to the old rich white guy that invented it in Western society.
Why is that bad to give him credit?
Because there's no guarantee that René Descartes did indeed invent it. We are just assuming he invented it because he is the first person in Western society that published it. It may have been used by somebody in India thousands of years before, or something like that. For example, the Egyptians were using pi long before the Greeks used pi, but they didn't call it pi. So we give credit to the to the Greeks for inventing pi.
Los Angeles doesn't celebrate Columbus Day anymore because
They shouldn't celebrate Columbus Day.
Columbus
Because first of all, Columbus was wrong. He just sailed and happened to hit land, as would anybody else who would have had the backbone to sail west from Europe. You couldn't not hit land. North America and South America go from the North Pole almost to the South Pole. All you had to do was be able to sail in a straight line. You would have hit it.
You don't even have to be able to sail in a straight
Yeah, you didn't even have to have a straight line. You would have had to deviate by like 20,000 miles to go around South America or hit ice up top. Up top. But even then they would have said, oh, look, ice. Wait a minute. There's no icebergs in India.
Or is there?
Or is, exactly. So anyway, yes, they have dropped Columbus Day from many, many places. That being said, they really shouldn't, because it is still a fairly heroic thing to do, to get in a boat and not know where you're going. Similarly, if we all got into a spaceship and just, eventually you'd hit something.
Hey, look, we found India.
Right? Yeah, exactly. We would not think that, though.
What if we found India in an alternate universe?
Oh my God. Yes.
Racist.
Yes. Okay, let's lawyer ball that up now. Okay, so this is X and this is Y.
That's nice.
Everybody good? What else do we know about this construction? We know there are 4. What do we call those? Leighton, do you remember? Starts with a Q.
For quadrants.
Quadrants. Excellent. Where is the first quadrant?
Up top.
Top right. Quadrant 1. And what do we know about X and Y in Quadrant 1?
Positive.
X and Y. They're both positive, yes? How do we label quadrants? Clockwise or counterclockwise or British anti-clockwise?
What's British anti-clockwise?
That the British do not say counterclockwise, they say anti-clockwise, which is why when I have to say clockwise, I say uncle clockwise.
Oh!
All right. So how do we label these bad boys? We label them counterclockwise. So this would be quadrant 2, yes? And what do we know about quadrant 2?
They're negative.
The X's are negative, Y's are positive. And what do we know about quadrant 3?
Both of them are negative.
Negative X, negative Y. And what do we know about quadrant 4? X is positive, Y is negative. Are we good with that for everyone so far? Yes. Everyone is good? Excellent. Okay.
Excellent.
I didn't even mean to do that, but now that you say it, damn, I'm funny. Why am I so funny? Oh, yeah, Lauren just did it too, though, at the same time. Lauren went, why do you have to point that out? You never do. All right.
Excellent.
Okay, so,
Excellent is EXE.
You need to accept it's funny.
all right. Now, in
Actually, don't get these things.
In the real world, if we were to count angles, we would start counting from N, north, correct? Right. This is not the real world. This is a mathematical construction. And we start counting from the x-axis, okay? Angles go this way, and they are increasing. Therefore, they are considered a positive angle. So, if I were to draw that line, this theta would be a positive angle. Everyone understand? And that theta would be some number between 0 and 90. Is everyone cool with that? Okay. If I go the other way, and I draw this line, then that theta would be what? A negative angle. Now this is where things start to get a little tricky. Triggy. They get a little triggy. Okay? Because how would I find this, do you think? Well, first of all, we would count this way, would we not? So that red line makes an angle, doesn't it? It makes a positive angle of 90, 180, 270, and a little bit more, yes? But that is the same as this side, which would be 360 minus that theta. Is everybody cool with that? Yes? Everyone is good? Everybody's happy? Everybody understands this?
I don't know if I'm happy, but yeah, I'm good.
Bless you.
Math.
Everyone's cool?
Yeah.
Okay.
It makes us math.
Now we got some work to do with that. I'm going to shrink this down so you can see, so I can have the definitions on the page along with the, thank you, the diagram. So it's going to be a little bit smaller for you guys, but you're tough. You'll figure it out. Okay, so an angle is in. Now, guys, please, it's capitalized, it's in bold. Is that term important? Yes. Standard position. An angle is in standard position if the vertex, what is the vertex of an angle?
The connecting part where it
The corner.
Yeah.
If the vertex is at the origin. What is the origin?
Little dot in the middle.
The big
Yes, and what are its coordinates? 0, 0. Okay? 0, 0. And it's, that's the wrong it's, dummy. And its initial ray is the x-axis. Now, using this black angle and this red angle, are both of those thetas in standard position so far? Is their vertex at the origin? Yes. Is one of their rays the x-axis? Yes. Everyone's cool? Okay. That, and I should have done it in a different color. I'll make it green. That is the initial ray. Everybody cool? Because we started counting from the x-axis. Everyone is good? Okay. The other ray. So I have the red line and the black line. Those two rays. Those are what we call the terminal arm. Because that is where the ray ends. It terminates there. And I'll highlight that in blue. Is everybody cool with that? Yes? Okay. If it is counterclockwise or anti-clockwise, we have what? Positive angles.
I hope you're regretting telling me.
And if it's clockwise, we have negative angles. Oops, I did that backwards. That was dumb of me. I should have done it the other way around. Black, counterclockwise is positive angles. And regular clockwise is negative angles. Okay? So I start on the x-axis this way. Should have done that black. This way is anti-clockwise, counterclockwise, so it is a positive angle. This way is clockwise, so it is what we call a negative angle. Is everybody good? Okay, now, that should be everything on your page, yes? All right, so you are moving on to page 73. I'm going to make this bigger, and I'm going to do the first one, and then you are going to take, actually, I'm going to do the first two. Then you are going to take over. Is 30 positive or negative? Positive, which means I start on what axis? The x-axis. Yes? And I go which way? Counter or clockwise? Counterclockwise. And I go 30. Where would that be? What section or what quadrant? Quadrant 1. There is the initial arm. There is the terminal arm. Everybody cool? Great. Let's do the next one. Where do I start counting? Right there. Is it positive? So do I go clockwise or counterclockwise? Counterclockwise. Which means I go 90. Then I got to go further. Can I go all the way to here? No, because it's only 135. There's my theta. There's my theta. That's my I. That's my terminal. Is everybody cool? Okay, the only thing I wish for you to do is change F to negative 115. Fill those in. Go.
F to negative 1.
Yep, make F negative 115.
What?
Nothing. That's funny. You guys done?
No.
Oh, well, okay.
No. I thought Taylor was the spokesperson.
Too bad.
I second
Taking
that.
over. No, you're not.
Okay, sorry, Mom.
Sorry, Mom.
I'm going to continue on. There's
Wait,
my...
so if it's negative, we go backwards.
Just stay cool, yes.
Go clockwise.
This has to come around. Will it get all the way to the bottom?
No.
No, down there. There's your theta. That's your initial arm, that's your terminal arm. 65 is in there. Terminal, initial.
I hope I did this right.
285.
Yes, I'm doing it right.
Initial, all the way around, 270 and just a little past.
Looks like that.
Terminal, initial. Now, negative 115. Terminal, I go down 90, 115, and out there.
I did it right.
There's your T, there's your I, there's your theta. Now, do not write this one down, but think in your head, what would 425 look like? Just think in your head, you don't have to draw it. A whole circle,
Plus a few.
360, plus another 45, or 65. Everybody understand? Is everybody good with angles in standard position?
Yes.
Going once,
Yes.
going twice,
Also yes.
going thrice.
Definitely good.
Okay.
What comes after first? There's no motion, Sam.
Yeah, there is.
Force? No.
Okay. Given an angle in standard position that you all just told me you understood,
Yes.
right? The reference angle is the angle between the terminal arm and the x-axis. Okay? So we are going to do a couple of these. Somebody give me a number between between 90 and 180.
106.
106. All right. So Taylor has given us a standard position angle, SP, of 106. Draw it on this first line. Where would it be? I'm going to draw it in red. There's my initial arm. Where would the terminal arm lie? Which quadrant? Second quadrant would be out here, yes? Where is the 106? Where the red dot is now, or where the red dot is now? First one. This is 106. So that is standard position. What then is the reference angle? The reference angle lives right in there. And how big is it? How are you going to find that? 180 minus 106 to get 74 degrees for a reference angle. Is everybody good? Yes? Okay. Now I am going to just draw some angles with no numbers to see if you actually understand the concept. Yes? Okay. I'm going to do the first one. Where is theta? Where do I start counting from?
From the x-axis.
Kind of looks like a snail falling off it.
Start counting there and then you go around.
So there is theta, yes?
V.
Where is the reference angle?
On the other little bit.
The little thing. It's like below, it's like beneath it.
Right here, yes? Because it's between the terminal arm and the x-axis. How will you solve that? Byron.
We estimate what the terminal arm is, and you subtract it from 270.
Subtract it.
270 subtract the angle that
You could do right there 270 minus theta. Would that work?
Yeah.
Would it?
No. Because, wait. Yes, it would.
No? Yeah.
Wait,
No. Because you had 270. So what minus theta would reduce the whole thing.
We should do 180 going
You just need to reduce.
180. It will
Oh,
work.
270 minus. It should be the.
Yeah. What are you saying?
Oh.
What can I say?
270 minus the theta.
No,
of
that
the
would work
reference
because
angle.
it's
work.
The
literally
reference
exactly
angle.
what we just did.
It's minus the theta of the reference angle.
Literally
It's
exactly
gonna
what you just did. You can totally do that.
It's raining out.
Yes.
I don't know.
It is 270 minus theta.
Because if you look at the last one, it's exactly what we just did.
Yeah, but like
the other angle.
if you go from the where the 270 is, the minus
It's
theta,
the same concept.
isn't the theta
Wait,
like
aren't you
almost
gonna
like
not get that?
245 basically?
Aren't you gonna get that angle there? You can't really see where I'm pointing, but that one.
All right.
That one.
No. Let's do another one.
Wait, so yes?
You can do that.
Where's theta?
Right between the arms.
So there's theta. What's the reference angle?
No,
The other
it's
one.
the same thing.
Yeah.
Same quadrant.
The theta is the reference angle.
Oh.
Because the terminal arm and the x-axis is still what we do.
That's like such a big reveal.
What's this one?
Oh,
Oh my.
so that the theta is on that side.
Where's the theta?
The theta is on the other side.
Out here or on this side or in here?
The other side.
Here's theta. So where's the reference angle? In there. And how do I find it?
Take theta.
360 minus
360 minus theta. Yes, Byron.
I'm pretty sure that the second one I did was because it said between the terminal arm and the x-axis. I just went to the y-axis.
No. That's not the reference angle. The reference angle is between the terminal arm and the x-axis.
Yeah, so I messed up.
Yes.
Yeah. Okay. Making sure.
Yeah. Is everybody good with concept?
Yeah.
Great. Let's do some actual math. Draw each angle and identify the reference angle. Where would 15 be?
In the first one.
Right here. There's the 15. So what's the reference angle? 15 is our standard position, and our reference angle is 15. Everyone understand? I'm not going to the next one until everybody understands. Yes? All right, 120 is where?
It's in the second.
Out here, yes? So there's the 120. That's my standard position. Where does my reference angle live?
Between the terminal and the x-axis.
What is it?
120 minus 180 minus 120.
180 minus 120, which equals 60. Mr. Grell, take it away.
Order, please.
Do you need anyone else?
Where's 250? This is the one that everybody was having trouble with on the last one. So there's 250. Yes? So where's my reference angle? In here. How do I find it? 250 minus 270 minus 250 is 20. Does that work?
Take away 180.
270 minus theta. That's what you guys all said to do. You said right there, I wrote it down. I know it's wrong.
That's why I said it's wrong.
But no, you didn't, Sam. You went, yes! No. Yes! No. Yes! No. Yes! No. No, Sam, we all watch you and you're still doing it. Yes! No. Yes! No.
I said it was wrong. And then you were like, it's right.
So what is it?
It's 260 minus 180.
It's really theta minus 180. The 75th time after you went.
No, I said it.
Take a chill pill.
So what is this guy's reference? 70 degrees. And finally 350. Where's that?
Oh, it's almost there. Right there.
So my reference is in there, and what is it?
Pac-Man.
It's 10, because it is 360 minus theta. Is everybody good? Yes? Yes?
I'm good. I second the motion to move on.
I'm just a little confused. So, the reference angle is
Oh, this is.
which side of the x-axis?
What do you mean, which side? So here is my terminal arm. Right? It started here, yes? Okay. So that's theta. So the reference angle is what's left over to the x-axis. So I'm not sure how.
Well, in C you got 70 degrees.
Okay, so
360. Which is 110.
C will go down there, yes? Okay. So this is 180, right? Theta was 250, yes? So all the way was 250. This much of it was 180. I need this difference in here. So it's 250 minus the 180 that I don't care about. And then you asked about 310, which comes all the way around to here, yes?
Oh, no.
If it went all the way, how big would it be? 360. But my theta right now is 350, yes? The whole thing would be 360, but I don't care about the first 350 of it. Because I only care about the reference angle, which is in there. Which is 360 minus theta, which is 350, which gives me 10.
Mr. Myers, do you have any whiteout I can borrow?
If only you were writing in pencil. Byron, are you good?
Yeah. It's one. I just don't get it. See, wouldn't the reference angle be on the outside, not on the inside of the angle? Because all the other
Okay,
ones-
again,
Yeah.
the reference angle is between the x-axis and the terminal arm. The x-axis is here. So the only spot for the reference angle is between the terminal arm and the x-axis. You good now? Okay.
I think he was thinking like between the other x-axis on the other side and the other quadrant, but it has to be in the same quadrant.
All right. Now, we are going to combine what we already know about the quadrant, about the coordinate plane, and what we already know. So all I want you to do here is draw these. So this is a point, yes? Where would it be? 3 here and up 2, yes? So that would be the angle. Does everyone agree? Okay. Where would this one be? You guys fill those in. I'll fill mine in a sec.
There. Like 5. Whoa! Training's so hard.
Wow, we live in Abbotsford. Have you never seen rain before?
What did I say? I don't know how to
So where would this one be?
Third quadrant.
Down here. Out 5, down 1. Where would this one be? Right 2, down 4. Where would this one be?
That would be second.
Out 10, up 5. Where would this one be? Out 4, up 2. This one? Left 4, up 2. This one?
Back 4, down 2.
Left 4, down 2. And this one? Right 4, down 2.
More noise.
Can everybody... That's impressive. The water falling off the roof.
It's like a waterfall.
The eavesdrops are clogged.
Let's go take pictures there.
Now,
It's like an aesthetic waterfall.
if everyone is good with that, then we are in good shape. Now, what should your...
Unit circle.
Straight to unit circle?
Yeah.
You guys don't have a page of work in there?
It's just unit circle.
What's the next page?
Massive empty blank space.
What's the next page? Son of a motherless goat. Okay, no problem. I should have given you guys, there should have been some work there.
Woulda, coulda, shoulda. Have you heard of Mama Mother?
Oh well, I guess you're getting out of today with no homework.
You don't know.
Oh no, we'll give you some. Page... Wait a sec. Just wait. Give me a moment.
Wait, so just to clarify, you gave us permission to have a Halloween party if we figure it out and bring all the supplies ourselves, correct?
My chat unite.
Oh!
The one where I don't say anything.
Yeah, she was
Mr. Myers, just letting you know we have a math class group chat.
to discuss our problems.
Terrific. Okay. Go on to page 75.
It's in the Happy Madison Productions, like the Adam Sandler.
Wow, you did a pop culture reference that nobody else did.
The unit circle should be page 75. Excellent.
Loving myself. Jeez.
Doesn't it have like a director for most Brad?
Exactly.
Okay.
An award for being warm.
Everybody put the following 4 dots on the little Cartesian plane there.
Well, that's racist.
Put
Okay, then we're talking. What?
Tell me the coordinates of this dot.
Sorry, can't.
Why not?
Because we don't know what the numbers on the X and Y axis
Absolutely, you don't know the numbers on the x and y axis. So what is the only thing you can call this dot?
X or Y.
X, y, correct?
Yeah.
What are the coordinates of this dot?
Negative X, Y.
Negative x, y. What are the coordinates of this dot?
Negative x, negative y.
And what are the coordinates of this dot?
Negative
No
x,
X,
negative y.
Agreed? Excellent. Have I made any angles? No. Make 4 angles. There's the first one, yes? We are only going to work with the first one. Can I do trig with that right now? Of course not. It's not an it's not a triangle. If I make it a triangle, what is my distance here? X. What is my distance here? Y. What is my distance here? X squared plus y squared square root. Right? Everybody cool with that? All right. What make this triangle now? I'm going to make it red. Well, it will be red. And then do the same thing. What's this distance? Negative x. What's this distance? Y. Now do the same thing. What is this distance? Still negative x. What's this distance? Negative y. And what is this distance? Still x. And what's this one? Does everybody agree?
Yeah.
All right, so now you should recognize that we have 1, 2, 3, 4 thetas, yes? What do we know about sine of every theta?
It's
Opposite over hypotenuse, yes?
Yes.
Look at this closely. Black theta, what's opposite? Y. What's the hypotenuse?
X.
It's right here, yes?
Yes.
H. Excellent. What is, yes. What is cos of black theta? A over H, which is what? X over what? Hypotenuse. Everyone agree? What is tan of black theta? O over A, which is what? Y over X. Everyone cool? Okay. Now, H is what? The square root of what? X squared plus y squared, yes?
Yeah.
What is H here? Square root of x squared plus y squared, yes? And we don't need an H there. Is everybody cool with that? Okay. You guys are smart kids now. What then is red theta's sign? Still O over H. Okay. What's opposite of red theta? Y. So it must be Y over what? Hypotenuse. What do I know about that hypotenuse and this hypotenuse? Why? Because x squared, even though it's negative, is the same as x squared, isn't it? So that's going to be the same. What's this guy going to be? Look closely. Negative x over h. And what's this guy going to be? Negative. No, sorry. It's going to be y over negative x. Okay. What about blue theta? Negative y over h, which is always what? Always the same. What's blue's cos? And what is blue's tan? Negative y over negative x. Hey, what do two negatives give us? Positives.
That's positively amazing.
And what's our green theta? What's our green sign? Negative y over h. Then what? X over h. And then what? Negative y over x. Now, all that should tell you something, shouldn't it?
It should, but I don't know.
You will know in a second. When I asked Lauren what this distance was, she said she didn't know. Why? Because I didn't give you any numbers, right? Yeah. Well, now I'm going to tell you that that is 4 and 7. X and y, yes? Sine is O over h, but what else is sine? Y over h. H is x squared plus y squared square rooted. So once I have the point, do I automatically know sine, cos, and tan for everything? Yes. Does everybody see why? I know. Let's end that joke, because, okay? Does everybody understand? So now that you understand the concept, let's use this big one to straighten things out. In this quadrant, x and y are both what? Positive or negative?
Positive. They're positively amazing.
Right? Which means sine equals positive over positive. Yes? X over y.
Yeah.
Not x over y, dumbass. X over h. Right? Cos is positive. Oh, not x. Idiot. Y. Positive over positive, so that's x over h. And tan is positive over positive because it's y over x. Everyone agree? So in quadrant 1, all ratios are positive. Does everybody understand quadrant 1? Please circle or highlight the A. Over here, x's are what? Negative. Y's are what? So, my sine is what? It's positive over hypotenuse, which is what? Can the hypotenuse ever be negative? How? It isn't, because every time you square something, you get a positive, right? So it's positive over positive, so it's y over h, yes? Yeah. What is its cos? X's are negative, so it must be negative over a positive. negative x over h, so it's negative. With me? And what's tan? Positive over negative because it's y over negative x. So what's positive in that? Sine, cos, or tan? What's positive? Sine is positive. Please highlight the S. What's going to happen down here? What's x? We'll finish this tomorrow.